Okay, and lastly, with heat problems, we're going to solve heat problems with a temperature change. So let's see an example. A 200-gram sample of water is cooled from, here we go, temperature change. How many joules of heat are released? Okay, so I need a different formula this time, so let's check it out. Temperature change right here. So Q equals mc delta T. M is mass, C is specific heat capacity, and delta T is change in temperature. Okay, so let's write this down. Q equals mc delta T. I have Q mc delta T. Now, delta T, okay, let me just write this up here. Delta T is the final temperature minus the initial temperature. So in order to find delta T, I need final temperature and initial temperature. Okay? So let's see, a 200-gram sample, that's mass, 200 grams, cooled from 70 to 214. So 72 degrees Celsius is initial. My final is 14. How many joules of heat are released? Okay, so I'm finding this. Those are just the units to remind me. But in order to find this, I need this. Well, this is easy enough to find with subtraction, these two. But I need this. How am I going to find it? Well, remember, it's water, so that allows me to use my reference table, excuse my cat, and look right here. Specific heat capacity of water, 4.18 joules per gram degree Kelvin. So, 4.18 joules per gram Kelvin. Now, these are in Celsius, so since this specific heat is in Kelvin, I should have Kelvin as my change in temperature. But here's something to note. If I add 273 to both of these and subtract them, I'm still going to end up with the same number for subtraction. But let's just, for the sake of being consistent, add 273. So 14 plus 273 is 287 Kelvin. And then 72 plus 273 is 345 Kelvin. Just be consistent. So how do I find the change in temperature? Final temperature, which was 287, minus initial temperature, 345. So 287 minus 345, and that equals negative 58 Kelvin. It's negative because it was being cooled, which means heat is going to be released. That negative sign indicates heat is released. So I'm going to leave that negative sign alone. All I need to do is plug numbers into the equation. So the mass, 200 grams, 4.18 joules. Remember when it's per gram degree Kelvin, like this. And my change in temperature, negative 58 Kelvin. So watch, grams, Kelvin, left with joules. That's heat, right? Okay, so let's do the math. So I already have negative 58 in my calculator, times 4.18 times 200 equals, okay, negative 48,488 joules. If I'm rounding to significant figures, this number only has 1. So if I'm rounding this to only one significant figure, well, that's this one. So that would be negative. And then I'm going to fill these in with zeros. Okay, there you go. Most of the time, you're going to be just fine giving this answer. But with significant figures, this is your answer. Okay, so let's look at another one. These are kind of the hardest problems. And 300 grams of ethanol is heated with 14,640 joules. What is the final temperature? Ooh, this one is even harder. Okay, so Q equals MC delta T. So I have Q MC delta T. Remember, that's final minus initial. So delta T equals final minus initial. Okay. Let's see what we got. We have 300 grams. So we have initial temperature. We have heat, 14,640 joules. And we have the specific heat, because this is not water, so that means they have to give me the specific heat, 2.44 joules per gram degrees Celsius. Notice, look, that one's in Celsius, so no conversion, leave it alone. Okay, so right now I have Q, I have M, I have C. So I can find delta T. So let's do that first. So 14,640 joules is 300 grams times 2.44. Remember, when it's per, those go on the bottom. Joules per gram degrees Celsius times delta T. Okay, so what cancels out? Grams. So I have delta T on this side, which I want by itself. So I need to move these over here. Okay. So what I need to do, I could first do this multiplication. Let's do that. That might simplify it. So 300 times 2.44 equals. So I have 732 joules per degree Celsius times delta T is 14,640 joules. So now, how do I move this? Well, remember I said when there's a top and a bottom, the easiest way to think about it is multiplying by the flip, by the reciprocal of that fraction. So by delta degrees Celsius over 732 joules. But I need to do that on this side, degrees Celsius over 732 joules. So you see, gives me this ability to cross out, this ability to cross out, plus the number, leaving me with only delta T. Over here, I can cross out joules, so I'm left with delta T. So I take 14,640 divided by 732 equals 20. So my change in temperature is 20 degrees Celsius. My initial temperature is 10 degrees Celsius. So there is a change, I know this now, 20 degrees Celsius. So my change is 20 degrees Celsius. All I need to figure out is, so the way I think about it is this says it was heated. Well, that means the temperature was increasing. What you can also do is this. This is positive, right? That's what I figured out. So 20 degrees Celsius is my final, which I'm trying to find, minus, my initial, which was 10. I need to add 10 to both sides, okay? But again, if you remember, it's starting here and being heated, okay? That would be 30 degrees Celsius, 10 plus 20. Adding 10 here as well. So same method, okay? And there are two problems, so this is one part. So we're going to do even more problems with this formula because these are the hardest ones. So I hope you learned something new, but there's going to be more examples.